And the chapter that we are going to do is solutions. Okay. So I see most of you guys are just for revision, I think. Now, what is solution? Solution is homogeneous mixture of two or more components. Two or more components. Okay, simply speaking, homogeneous mixture of two or more components. Okay. Other thing is that what are those two components? Generally, we have two components, and please write next point. Solutions with only two components are called solutions with only two components are called binary solutions. And in your 12th standard, you have to deal only with binary solution. That means a solution which has only two components. Okay. Now, the binary solution, they have two components, and these components are known as so if you have two components, one will be in major amount, the other will be in minor amount. So here you can write these components are known as solvent, which is I will represent solvent by A, solvent, which is the component in major amount. Component in major amount, and you have solute, that is B, component in minor amount. Component in minor amount. Okay, so these are generalized definitions. These are not very restricted definitions. Okay, these are not very strict. That, for example, if I have also generally, I would also write one more thing. Generally, when something is added to water, then water is considered solvent. Okay, so we generally assume water to be solvent. A solute is something, a very generic idea. If you have like too much of things, na, like you see many people, they ask, sir, what will happen if I have 50 gram of water and 50 gram of salt? Then what will be solute and what will be solvent? So obviously water is going to be the solvent in all of these cases. Even if you take 80 grams of sugar and 100 grams, 80 grams of sugar and 50 grams of water, or 60 grams of water, then also water is going to be the solvent. So again, these definitions, that solvent is the component in major amount or the solute is the component in minor amount, that are not very strict definitions. I generally assume that solute is something which gives the property to the solution, no matter the amount. Okay, so when you are going to drink a glass of water which is having a lot of salt in it, you will say there is salt in it, you will not say there is water in it. Okay, so you imagine solute and solvent in that sense, if you have confusion. Okay, otherwise these definitions are fine. You will you can easily assume what is the solvent and what is the solute. Don't go with these definitions very strictly. Okay, now also one more thing, as I said, a solution is identified by the solute in it. Furthermore, a solution is identified by the amount of solute in it. First of all, what is the solute and how much it is present? Okay, what is the solute and how much it is present? So what is the solute can be different thing. Many things can be added in water or any other solvent for that matter. But the amount of solute can be generalized, and there can be certain things which can be representing the amount of solute in solvent, and those things are known as concentration terms. Okay, so for example, if you have ruafza and ruafza has a little less sugar or little less ruafza, then people generally don't say that we have more water in it, है ना? पानी ज़्यादा ऐसे नहीं बोलते, लोग बोलते चीनी कम है और ruafza कम डाला, right? So obviously we represent each and every solution, and each and every solution is identified by the solute and the amount of solute. So we have concentration terms. Now the concentration terms that we have to study exactly are: number one, you can say we have mass percentage. Secondly, we can study volume percentage. Thirdly, we can study mass by volume percentage. Fourth, we can study parts per million. By the way, mass percentage is given by percentage W upon W. This is given by V by V. This is given by W by V. Parts per million is shown by ppm. Now, after parts per million, we will study molality, mole fraction, and seventh is molarity. Okay, so molality is given by small m, mole fraction is given by chi, and molarity is given by capital M. Okay, so in this, please listen, I will discuss all of these very slightly because they are not very important, in the sense that will not be asked numericals from these mass percentage, volume percentage, and mass by volume percentage. Rather, these things will be given as information in the question. They will give you a solution contains this percentage, this percentage W by W of solvent. And also parts per million is a very small topic. I will discuss it very slightly. Molality, mole fraction, and molarity, these are important. So we are going to do numericals on these things: molality, mole fraction, and molarity. If you see the NCERT, maximum weightage is on this mass percentage, then molality, mole fraction, and molarity. You cannot skip these. Okay, you cannot skip these. You can skip more volume percentage, you can skip mass by volume percentage, you can skip parts per million also, but you can't skip these four. Okay, mass percentage, molality, mole fraction, and molarity. Okay, now can I move on? All of you wrote this? Yes or no? Please tell me. Anji, बताएं. All of you done? Anyone still writing? Please let me know. Okay. Now, all the concentration terms which deals with percentage. Which deals with percentage, whether it be, please see here, don't write anything, mass percentage, or it is volume percentage, or it is mass by volume percentage. For all of these things, they give you some information. They give you some information. So if they are talking about mass percentage, then you will say, for example, if you have X, if you have mass percentage, then it will be grams in 100 gram of solution. Percentage ka matlab whatever percentage is given. For example, they are giving you mass percentage is equal to X, right? Some X per 7%, 7, 8, 9, 10, whatever percentage is that. So that X grams in 100 grams of solution. If they are talking about volume, and they have given volume is X percentage, then it will be X ml in 100 ml of solution. If they're talking about mass by volume percentage, then they're saying X grams in 100 ml of solution. Okay. Now, I hope there will be not much difficulty in understanding these terms. So let me give you some examples and extract the information that we are having. Try to extract the information that these mass percentage, volume percentage gives. Okay. So let me separate this rather with some distinct. Yeah. So okay. Now, for example, you have been given 10% of NaCl aqueous, 10% of NaCl aqueous by mass. Okay, or in bracket there is W by W. Then from here you can represent, you can find out three things. First of all is the mass of solute. Remember, B is for solute. Then you can find out the mass of solution. Okay, mass of solution. I will write W solution. And you can also find out the mass of solvent very easily. How? See, X gram in 100 gram of solution. So 100 gram of solution is there and you have X gram. What is this X? X is the mass percentage. What percentage is here? 10%. So 10 gram. The mass of solution will be 100 gram. And what will be the mass of solvent? It will be the mass of solution, that is 100 minus WB. So explicitly telling you that it is going to be always 100 minus whatever the X is, and the X here is 10. So it will be equal to 90 grams. So 90 gram of solvent plus 10 gram of solute, it is going to make 100 grams of solution. All of you understood this? Yes or no? Please tell me. Anji, please bataye, let me know if you don't understand this. For example, if you have 27%.
Can you repeat it?
So just a second. Try to understand here, Fia. Okay. And ask me if you have doubt here. Okay. Can also keep your mic on. Ethanol. V by V. Fia, can you keep your mic on?
Yes, sir.
So here we are dealing with mLs, right? So I can tell 27%. I can tell the volume of solute. I can tell the volume of solution. And I can also tell the volume of solvent. Okay. So if you have volume percentage given as X, what does it mean? Read it, Fia.
It has some value, sir.
Sorry? No. Can you read this statement? If volume percentage is equal to X, it means?
Sir, it will be 27.
No, you read this statement, no, whatever is written. Read first, if volume percentage is equal to X, then it means?
In 100 ml of solution.
Read this properly, X ml in 100 ml of solution. What is X here?
X is the solute, sir.
What percentage of X is there? What is the amount
27.
of X? 27. What's the value of X? 27. So what will you read? 27 ml in
100
100
ml
ml of
solution.
Solution. So solute is how much? 27 ml. Solution is how much?
100 ml.
100 ml. And what is the solvent?
100 minus 27.
100 minus 27. You understood for the mass percentage also now?
Yes, sir.
Okay, so what will be this? 27. 100 minus 27 will be? Hmm. 100 minus 27 will be 73 grams, right? Okay, now listen here. This one is important. For example, if you have been given, let us suppose you have 15% mass by volume will be W by V of aqueous, let us suppose what? NaOH. Okay. Now here I can say that the mass of solute is equal to 15 grams. And I can also say the volume of solution is 100 ml. But I cannot, I cannot say the volume of solvent or the mass of solvent, anything, because they have different units, right? Both of them have different units, so I cannot add or subtract them. I hope you can remember something from the first chapter of physics, unit dimension and measurement. You can add and subtract only those things which have same units. In any formula you see, you will add and subtract only those things which are having same formula, sorry, same units. If the units are different, you cannot add them or subtract them. Okay, it's not going to give you any value here. For example, if you want to do it, you can do it like this. You can say 100 minus 15, but it's not actually 100. It is actually 100 ml minus 15 grams. So this ml and grams, they can't go together. It's just like doing 100x minus 15y. You cannot solve this furthermore, right? So this cannot be solved. That is why you cannot determine anything else. So if you have mass percentage, if you have mass percentage and volume percentage, then you get three informations. You get the mass of solute, the mass of solution, and the mass of solvent. Volume of solute, volume of solution, and the volume of solvent. But in mass by volume percentage, you only get the mass of solvent, sorry, mass of solute, and the volume of solution. Okay, please write this down. Let me know once you're done. So as soon as you see something like this, 10% by mass or 10% W by W, then please write these three things. As soon as you see, if you are seeing 10% NaCl, your mind should be seeing mass of solute is 10 gram, mass of solution is 100 gram, mass of solvent is 90 gram. You should not even see the 10%. Okay, you should be seeing these three things given. And this is the major problem that you will be facing in starting with the solution chapter in physical chemistry, that most of the time you will be thinking that all the information is not given, some information is missing. It's not the actual information which is missing. You're not applying those things. So try to see these 10% as mass of solute, mass of solution, and mass of solvent. Is everyone done? Yes or no? Please tell me. All of you done? Anyone still writing? No one is writing. Okay. Right, next, so we have discussed three. Right, next, that is parts per million. Now, I just want to relate this with the mass percentage. Okay, so parts per million will be equal to ppm, will be equal to parts of solute divided by total parts of solution. Now, when you are trying to determine the percentage, to multiply by 100 percent. If you are having percent, you multiply by what? 100. But if you are having per million, you will multiply by 10 to the power 6, that is million. Okay, so now this parts, what is parts? Parts can be either mass or volume, है ना? आप ऊपर में mass ले सकते हैं, नीचे में volume ले सकते हैं, ऊपर में volume, नीचे में mass, you can take anything, है ना? There is no restriction in ppm. In ppm, the numerator can have, what? Mass, denominator can have volume. You just don't need to see those things in parts per million. Okay, so this is parts per million. Very simple. One thing that I want to just show you guys here is ppm will be equal to, if I take this whole thing and rather than writing 10 to the power 6, I can write 10 to the power 6 as 100 into 10 to the power 4. Now, obviously 100 is equal to 10 to the power 2. Now this whole thing will become percentage. And if the parts are given in mass, if it is given in mass, then I can write ppm is equal to mass percentage into 10 to the power 4. This becomes what? This becomes mass percentage. If parts is given in mass. All of you done? Yes or no? Please tell me. Achha, let me know if someone is writing. Okay. Please let me know if someone is writing. Okay, no one is writing. Okay. Now, moving on to molarity. First of all, we'll see molality. Then we'll see mole fraction, and after that, we are going to see molarity. Now, all of these, they include the term that is moles. So many people, they don't remember moles from the 11th standard. So first of all,
Sir,
write
can
what
you
is.
show the parts per million, sir? Just a minute.
No problem.
Yes, sir, done.
So please write here about moles. Okay. So mole is equal to 6.022 into 10 to the power 23. This is mole, but mole can be calculated in 3 different ways. If you don't remember this, please write these formula. Number 1 is that we are going to use mostly mole. It is equal to number of moles, rather I would write. Achha, it is represented by n. Okay, is represented by n. So number of moles n, it is equal to the given mass divided by molar mass. Okay, so we generally represent given mass by W, and we generally represent molar mass by n. Second formula that you are not generally going to use this, but number of moles is equal to given number of particles divided by 6.022 into 10 to the power 23. Thirdly, you have number of moles, it will be equal to the given volume divided by 22.4. Now this one is only for gases at STP. Okay. So remember this one, this is very important, that number of moles will be equal to the given mass divided by molar mass. Okay. So this is going to be important. W by M, that is given mass by molar mass. Also, there are a few relationships that we are going to use. Write some notes here. First note is regarding the density. Okay, we are going to use the word density here. So you should remember what is density. Density is equal to mass by volume. Okay. So from here, you can see many things. Mass will be equal to density into volume. Similarly, volume will be equal to mass by density. Once again, mass percent parts per million. कहाँ scroll up करना है? अच्छा, if you want to scroll up, please turn your mic on and tell me कहाँ तक scroll up करना है. I've just written moles, nothing else. Write this down quickly, guys. And also one more thing is that density of water, density of H2O, it is equal to how much? It is equal to 1 gram is present in 1 ml. Or you can write 1 kg in 1 liter. 1 kg per liter, 1 gram per ml or 1 kg per liter. Okay, this is the density of water. एक और इंफॉर्मेशन जो आपके बहुत हेल्पफुल होने वाली है. Right, next. Number of moles. Right, I mean, do it in terms of questions. Okay, so calculate number of moles in 1 liter of water. Okay, so generally people, when they see liter, they use this formula, that is given volume by 22.4, but that is wrong because water is not a gas, water is liquid. So actually this question requires you the knowledge of density of water. So you'll write, since density of water is equal to 1 gram per ml, which will be equal to, if you multiply 1000 here and 1000 below, you will get 1000 grams in 1000 grams per liter. So 1000 grams present in 1 liter. Therefore, you want to calculate the number of moles in 1000 gram of water. Okay, so the given mass of water, W, it is equal to how much? Right, number of moles will be equal to the given mass divided by of what? Given mass of H2O divided by the molar mass of H2O. So given mass of H2O is 1000 grams divided by molar mass of H2O is equal to how much? It is 18 grams per mole. Okay. Don't worry about the units right now. Grams and grams will cancel out each other, and you can see 1000 upon 18. Now, number of moles can be equal to 1000 upon 18 moles, or you can write it in terms of, even if it is in fraction, don't worry. Okay, so you can write 500 divided by 9 moles, and which will be equal to 55.55, or you can also use the value 55.56, whatever suits you. Okay, so if there is something, it is it is an even number in the numerator and denominator, and you have to use the number of moles of water, so you'll be using 55.56. If there's some numbers like 15 and 20 or 100 with multiples of 5, then we are going to use 55.55. And so you can use both the values. It's not going to matter much in the answer. But time is going to matter. That is why we will be using this liberty of 55.55 or 55.56. Please write this down quickly so we can discuss the next 3 concentration terms and 1 question. Anyone still writing? Anyone still writing? Okay. Now write the 5th concentration term. Molality. What is molality? Molality is represented by small m. Please write number of moles of solute per kg of solvent. Molality is number of moles of solute per kg of solvent. Now, the formula will be, molality will be equal to the number of moles of solute. That means it is number of moles of solute means NB divided by the mass of solvent. So mass is represented by W. For solvent, we are going to write A. And this A, mass of solvent in A, that will be in kg. So from here, we can see that number of moles, its unit will be mole and per kg. So mole kg inverse, or we also call this molal, or we just write m as the unit. Okay, so all of these things can be used as unit. One more thing that I will tell you very clearly, mole per kg is something that you are going to use. So when you are writing the answers, you generally use mole per kg. But in the question, if molality is given as an information, they will either use the word molal or they will use the small m. So if they have given, for example, 2.5 m of aqueous NaOH. Now, these are the translations which are very important. Okay, so 2.5 n, what does it mean? It means 2.5 mole per kg. That means mole of NaOH in 1000 gram or 1 kg of H2O. 1000 gram of water. Now, as you can see, it was only one number that was the information that you had, right? And you even did not have the information completely. when they wrote 2.5 m. But now you have bisected and you have got the complete information that we have 2.5 mole of NaOH in 1000 gram of H2O. So you have now the moles of NaOH, and then you also have the mass of the solvent. And if you have the moles of NaOH, then you can use the formula. Number of moles will be equal to the given mass by molar mass. So this N is 2.5. Given mass you don't know, but you know the molar mass of NaOH to be 40. So if you multiply this, then it will be equal to how much? 40 to the 80 and 190. So W will be equal to 90 grams. So see how much information is present in this one, like one number, 2.5 mole. You have got the mass of solvent. You have got the mass of solute also. Okay. So you have to dissect these information like this. Okay. So that this is how you are going to use molality if it is given as an information and not something that you have to calculate. Now, if you have to calculate, then please see, I can write molality as number of moles. I can write it as the mass of solute divided by the molar mass of the solute multiplied by the mass of solvent. Generally, mass of solvent will be given in grams. So in order to convert grams to kg, what I need to do, I need to divide by 1000. And there is something that I repeat always, is that denominator of denominator is numerator. So 1000 will go above. And this is the formula that you are going to use in the numericals. But always remember, the original formula is this. So if they have given already number of moles, then you don't need to put this formula, okay? But mostly you will be using this formula only. Most of the questions you will be seeing in boards or in your term 1 examinations or in NCERT also for that matter, you will be using this formula. All of you got this? Yes or no? Please tell me. If you have any doubt, please let me know. And please revise these things, okay? And while you are revising, try to teach these things to yourself. Don't try to remember these formula always. So you read the definition, number of moles of solute per kg of solvent. That itself is going to give you the formula. Number of moles by mass of solvent in kg. Now you just need to bisect. Number of moles will be equal to WB by MB. Mass of solvent is generally given. Generally take it in grams only, right? If you have small container beakers होंगे, तो वहाँ पे आप grams में लीजिएगा, kg तो वहाँ आएगा नहीं. So you take it in gram, divide by 1000, and denominator of denominator becomes numerator. So you have 1000 above, and WA can be written in terms of grams only, and you can directly plug in the values. All of you got this? Yes or no? Please tell me. हाँ जी बताएं. All of you wrote this? Let me know if you have any doubt, guys. कुछ आप लोग हाँ ना तो कुछ नहीं बोलते हैं. Right, the sixth part. क्लास करना है तो भाई प्लीज एटलीस्ट एंगेज कीजिए, वरना हम बंद कर देंगे क्लासेस. Right, the sixth one, that is mole fraction. Mole fraction is represented by chi. It looks like X, but it is a Greek letter, I think, which is pronounced as chi. No, CHI chi. Okay, now what is mole fraction? It is usually the mole fraction is also determined for a component. It is determined for a component. So it is the number of moles of the component divided by total number of moles in solution. And since we are dealing with binary solutions, so you'll write for binary solutions, you can define chi A, that is the mole fraction of solvent, which will be equal to the number of moles of solvent divided by number of moles of solvent plus number of moles of solute. Similarly, I can define chi B, the mole fraction of solute, as number of moles of solute divided by the number of moles of solvent plus number of moles of solute. Now, if you look at these, both of them, then you can also determine a relationship that chi A plus chi B will be equal to, see, chi A is number of moles of A divided by number of moles of A plus B, number of moles of B divided by number of moles of A plus B. Now, both of these are having same denominator, so I can just write them like this: number of moles of A plus number of moles of B. Now, for chi A, I have number of moles of A. For chi B, I have number of moles of B in the numerator also. Now, both of these values will be equal, so I can write chi A plus chi B will be equal to 1. Chi A plus chi B will be equal to 1. This is an important conclusion that we are going to use in many of the problems. Please write this down. Let me know if someone is still writing. Now, 6th, 7th one is, please write. Molarity. 7th one is molarity. What is molarity? It is number of moles of solute per liter of solution. So it is represented by capital M, molarity. So molarity will be equal to number of moles of solute NB divided by the volume of solution in liters. Now the unit of this is going to be number of moles will be in mole per liter, that means liter inverse. Or as an information, it will be given as molar, or it can be given as capital M. For example, if they are saying 2 molar aqueous ethanol, then the meaning of this is 2 moles of ethanol in 1 liter or 100 or 1000 ml of solution. Okay, so sometimes you can use this formula. Please see, molarity will be equal to the given mass, that is WB, divided by MB, molar mass, multiplied by the volume. Generally, if it is given in ml, then you multiply 1000 above. See, write this down. That is molarity. Now we are going to look at a question. There is a very good question in NCERT. Whenever you want to revise concentration terms, I suggest all my students to do this question. Okay, they write this down and we'll see that question. This is a very basic revision that you can have for concentration terms. And the most basic question that you can do to revise, just to know that whether you can deal with numericals or not, or if you are able to revise. So if you are able to retain the formula of molality, and mole fraction, then this is the question. Calculate molality, and mole fraction of Ki if density of 20% mass by mass aqueous Ki is 1.202 gram per ml. Now there is one information that they have not given, which should be present, is the molar mass of Ki. So molar mass of Ki I will give you, don't worry. Please write the molar mass of Ki is equal to 166. Is everyone done writing for molarity? Please write this question. Molality, mole fraction of Ki if the density of 20% mass by mass. Now, first thing that you should do is, now always remember, you don't need to find what they have actually given. You need to find whatever you can find. Okay? Don't have a habit in your brain whenever you're dealing with physical chemistry questions. Don't think that you are going to look at the question and you will know how to do it. No, sometimes you won't know how to do it. So what you are going to do, you are going to find whatever you can. Anna? So from here, you start writing. Okay. First of all, another thing is that you start writing. For example, as soon as you see 20% mass by mass, your mind should say, okay, fine, please write WB is equal to 20 gram. Then please write W of solution, it is equal to 100 gram. Please write mass of solvent, it is equal to 80 gram. Then you will see, okay, aqueous. That means B is what? H2O. Sorry, my bad. We have solvent, that is A. It is equal to H2O. What is the molar mass of H2O? Molar mass of H2O will be equal to 18 grams. Okay, 18 grams. Then I can also find the number of moles of A. Number of moles of A will be equal to 80 upon 18 grams. Okay. Now I am not finding anything what they're asking. I'm just finding whatever I can. Okay. This is for somewhere. This is if you are not, if you don't know what to do. I'm assuming you don't know what to do. You find whatever you can and then things will plug in. Okay. I have also the mass of solute. So I can calculate the number of moles of B, which will be equal to how much? It will be equal to 20 divided by 166. So say, oh my God, I have number of moles of A and number of moles of B. Then I can easily find the chi B, mole fraction of the solute, which is equal to number of moles of B divided by number of moles of A plus number of moles of B. तब अब मोलालिटी देख के ऐसा नहीं ना कि आपको मोलालिटी फाइंड करने लग जाना सबसे पहले. Are you guys getting what I'm trying to say? Yes or no? Please tell me. Deborah, Iram, Fia, Tarif, and Chavez. You're understanding what I'm trying to say? How to deal with numericals? ठीक है. क्वेश्चन आपको घुमाना चाहेगा, आपको घूमने की जरूरत नहीं. जो दिया है उससे जो कुछ निकल रहा आप निकालिए, आपको आंसर वही दिखेगा. उसी तरह से ब्रेन वर्क ही करता है ना. आप घर में बैठे रहोगे कि मतलब आपको कोई रास्ता है देख पाओ, है ना. आप एक दो बार गए हैं, आप इसी डर से कि निकलो ही मत कि भटक जाएंगे. ऐसा भी तो हो सकता है कि कोई दुकान आपको याद है, अच्छा हाँ यहाँ से ये दुकान, यहाँ से राइट लेना, यहाँ से हमने राइट लिया था, यहाँ पे चॉकलेट लेने के लिए उतरे थे. आप स्टार्ट तो करो. ठीक है. You have been to these places ना, molality, mole fraction once in theory at least. So you start doing these questions, then only you will understand. चलिए, ये तो बात हो गई. You can now easily find out what the mole fraction of the solute. You can just plug in the values and then it is calculation. अब आप calculation से घबराएंगे तो उसका कोई इलाज दूसरा है नहीं. ठीक है. Now moving on, please see. Once you are able to, tell me.
So mass of the solvent will be 80 grams, right?
Mass of the solvent will be 80 grams. Na में 80 by 18 ठीक लिखा ना हमने. Given mass by molar mass ना Iram.
Sir, I'm asking about the MA.
MA, that is molar mass. M होता है molar mass के लिए, A W को लेते हैं given mass के लिए. ठीक है. बात समझ में आई नहीं आई?
Yes.
ठीक है. MA is molar mass of solvent, that is 80. ठीक है. चलिए. Fair. Now you see here that we have molality. You have molality. अब molality करना बहुत आसान हो गया ना आपके लिए. तो molality के लिए सारी information आपके पास है ही. See, molality is small m, which is equal to what? If you know the formula, just flip some pages, you will get the formula. WB है मेरे पास. WB, I have WB, that is 20 into 1000 divided by MB. I have MB 166 multiplied by 80 WA. Molality आ जाएगा. Whatever the answer is, you will get it in moles per kg. आया ना बोले भाई. All of you got this, yes or no? हाँ जी. What about others?
Yes, sir.
ठीक है. अब आते हैं मोलारिटी में. फॉलिंग इनटू द ट्रैप की मोलालिटी पहले तो मोलालिटी निकालना, मोलालिटी बाद में उसके बाद बोल रहा है नहीं, जो आ रहा है वो निकालते जाए. ठीक है. व्हाटएवर यू कैन फाइंड आउट, प्लीज कैलकुलेट दैट. यू कैन गेट द मोलालिटी इजीली फ्रॉम हियर. मूविंग ऑन टू मोलारिटी. नाउ if you don't know how to calculate, then you are going to write the formula. Molarity is equal to, what is molarity? Molarity, it is equal to, please write here like this. WB into 1000 divided by WB into 1000 divided by MB into the volume of solution. Volume of solution. I don't have the volume of solution, but what do I have? I have the mass of solution, and they have given me density very easily. They have given me the density very easily. So I will calculate वॉल्यूम इट इज इक्वल टू व्हाट, सी सारा कुछ जब हमने ना इसी वजह से नोट्स में लिखाना चालू कर दिया है। हाँ ये देखिए, वॉल्यूम इज इक्वल टू मास बाय डेंसिटी, सो इट इज देयर इन योर नोट इटसेल्फ। आपको कुछ याद करने की जरूरत नहीं, आप बस नोट्स के एड्रेस को अच्छे से याद रखें, ये चीज यहाँ है, ये चीज वहां है, दैट्स इट। ठीक, सो वॉल्यूम इट इज इक्वल टू व्हाट, इट इज इक्वल टू डेंसिटी बाय मास। व्हाट इज डेंसिटी? 1.202, 1.2 लेंगे हम, 0.2 क्यों ले? सवाल आपको घुमाना चाह रहा है, आपको घूमने की जरूरत है नहीं, 0.2 से क्या ही होने वाला है। I will take 1.2 only, density divided by, it is mass divided by density, no, sorry. Mass is what? Mass is 100 divided by 1.2. Mass divided by 1.2. कोई घबराने की जरूरत नहीं है आपको, प्लीज देखिए। This will be equal to, सेम इसी को प्लग इन कर दीजिए। WB कितना है अपना? 20 into 1000 divided by 1000 divided by MB कितना है अपना? MB is 166 multiplied by 100 divided by 1.2, ऊपर जाके 1.2, denominator of denominator is numerator, it will be equal to 20, 20 cancel, 10 into 1.2 will be equal to 12, 20 into 12 divided by 166, whatever the answer, it will be in moles per liter. and बोले भाई hard है, tell me guys. One thing will be problematic if they don't give you the molar mass of Ki, है ना? If they don't give you the molar mass of Ki, in the boards I am saying what to do. ठीक है? In the boards you assume the molar mass of Ki to be X, or you just assume it to be M or something like that. ये क्या हो रहा है मेरे साथ? एक सेकंड, why it is getting below? Just a second guys. वैसे भी क्लास खत्म होने वाली, still what is happening? ठीक हो गया। Okay. So what I am saying is that if they have not given the molar mass of something, na, you assume it to be M. कुछ आप नंबर नहीं, कुछ आप उसकी वैल्यू ले लें, like some variable X मान लें उसको, या फिर आप just मान लें MB, and you calculate the whole thing using MB. I don't remember what set or what paper was it in 2023 only. I was looking at the mark scheme that was provided by CBSE, and they have not given the molar mass of urea. अब यूरिया क्या है पता है? यूरिया आप लोग को पता होना चाहिए। NCERT at least I thought that NCERT expect करेगा कि आपको यूरिया का पता है। जब हमने सवाल देखा था, they have not given the molar mass of urea. ठीक है, so I saw, let us see in the mark scheme that how they treated this question, है ना? तो उन्होंने आंसर में लिखा था यूरिया का मोलर मास, it is what? NH2 CuNH2। ठीक है, so most of the student can easily find, but they have not also given the formula of urea. वो यूरिया बस लिख दिया था उन्होंने, तो शायद इसी वजह से उन्होंने दो आंसर्स दिए हैं। एक तो मोलर मास यूरिया का लिख के कि मोलर मास कितना, आई थिंक इट इज 60, नाइट्रोजन इज 14 14 16 16, and then you have carbon 12 plus 16, so 16 3s are 48 and 12 16 ना। तो एक तो 60 लेके उन लोगों ने किया, एंड दूसरा उन लोगों ने बताया MB लेके। नो if they don't give you the chemical formula also, then I'm saying, ठीक है। अब भली बात है KI का उन्होंने पूछा, तो आयोडीन का किसको याद करना है? याद कराने के लिए चीजें नहीं है यहाँ पे, ठीक है। सो अगर आपको मोलर मास नहीं पता है, ठीक है, और ना ही एग्जामिनर ने दिया है, तो आप उसको MB मान के सारा आंसर सॉल्व कर देंगे, आपकी MB के टर्म्स में आंसर आ जाएगा। फॉर एग्जाम्पल ये वाला जो आंसर है आपका मोलारिटी वाला अगर आपको मोलर मास नहीं दिया हुआ तो आपको क्या लिखना है? 12 2 इट विल बी 24 और एक 0 डिवाइड बाई MB, दिस विल बी योर आंसर। हम आपको दिखा देंगे, अभी ध्यान नहीं, हमको ढूंढना पड़ जाएगा थोड़ा कि कौन से पेपर में उन्होंने इस तरह से बोला था कि इफ दे टेक MB देन गिव देम कंप्लीट मार्क्स काटने की जरूरत नहीं, ठीक है। सो अगर आपको मोलर मास नहीं पता है तो आपको डरने की जरूरत नहीं है, पूरे सवाल को कर लीजिए, जो आंसर आ रहा है उसको वैसे ही रख लीजिए, ठीक है। विल गेट कंप्लीट मार्क्स, एक मार्क्स भी डिडक्ट नहीं है। अनदर थिंग दैट you have to be very careful about is the units. All the questions which are dealing with, which have answer and the answer has some units, उसके सेक्शन में हमेशा इस तरह से लिखा रहता था, इसी में हमने देखा है, ब्रैकेट में लिख देते हैं डिडक्ट 1 मार्क्स नहीं, 1 मार्क्स नहीं, सॉरी, हाफ मार्क्स, डिडक्ट 0.5 if no or wrong units। ठीक है, तो यूनिट्स का आपको बहुत ही ख्याल रखना है। अगर गलत हुआ या फिर आपने यूनिट्स नहीं भी दिए हैं तब भी आपके मार्क्स कट जाएंगे। यूनिट्स का बहुत अच्छे से ख्याल रखेंगे। चलिए अब इस सवाल को आप लोग आगे सॉल्व कर लें, ठीक है, एंड रीडू दिस क्वेश्चन। देयर आर सम होमवर्क दैट आई एम गोइंग टू गिव यू फ्रॉम एनसीईआरटी। काफी आसान चीजें हैं, कुछ खास उसमें है नहीं, 4-5 सवाल है, उनको कर लीजिएगा बस। in text questions 2.1 2.2 2.3 2.4 हाँ चलिए in text okay। ये सारे सवाल हैं, इनको कर लीजिएगा, ठीक है। अब उसके बाद ऑल्सो रीड एनसीईआरटी, है ना, ऑल्सो रीड एनसीईआरटी। खास तौर से एनसीईआरटी में ना जो कंसंट्रेशन टर्म्स का आखिरी जो पैराग्राफ है वो काफी इंपॉर्टेंट है, उसको पढ़ लीजिएगा। इट इज टॉकिंग अबाउट टेम्परेचर इंडिपेंडेंट एंड टेम्परेचर डिपेंडेंट कंसंट्रेशन टर्म्स, ओके। सो 2.1 से पहले यू विल सी एन एग्जांपल 2.3 करके कुछ एग्जांपल है शायद, ये इट्स 2.3 एंड उस एग्जांपल से पहले वाला जो पैराग्राफ है दैट इज इंपॉर्टेंट। Each method of expressing concentration of solution has